Chapter 5, Number 39. During an episode of turbulence in an airplane, you feel 190 newtons heavier than usual. If your mass is 780 kilograms, what are the magnitude and direction of the airplane's acceleration? So the first thing is we figure out what your true weight is, because we're going to be using that throughout the whole problem. So your true weight is just your mass times g. So in this case, 780 kilograms, or 78 kilograms times 9.81 meters per second squared, which is 765.18 newtons, which, with only 2 digits of accuracy, we probably should call 770 newtons. The next is we should draw a free body diagram for you, the person. And for the moment, we're going to pretend that you are standing on a scale in the airplane. So here's you, and here's the scale, and you're standing on the scale so that we can read the scale says. And that says our scale reading, according to this problem, the scale reading is 190 newtons heavier than normal. So your normal 770 plus 190 newtons, which is 960 newtons. Alright, and then what's going on if we do a sort of a free body diagram of you is that the weight is pulling you down, but the scale is holding you up, and then there's an acceleration which I'm going to choose to point upward and then see. If it comes out negative, then I just know it really went downward. And what we have here is we say from our diagram, the sum of the forces is Fs minus Fg, and from Newton's second law, the sum of the forces is Ma, which tells us that Fs minus Fg is the mass times the acceleration. Which means actually I guess I never really needed the Fg, because all we care about is Fs minus Fg, which was given to us as 190 newtons. And that should equal to 78 kilograms times A. Or A is 2.4359 meters per second, which is really 2.4 meters per second square because of sig figs. Also, since it came out positive, it means my arrow is in the right direction, so it is upward.